All right. Hello, everyone. Welcome to our computer science seminar today. I'm Rebecca Wright, Director of Computer Science at Barnard, and our speaker today is Smaranda Muresan. Dr. Muresan is a research scientist at the Data Science Institute at Columbia University and an Amazon Scholar. Before joining Columbia, she was a faculty member at the School of Communication and Information at Rutgers, where she founded the Lab for Study of Applied Languages, Technologies, and Society, and where we were fortunate enough to get to meet and interact then. She was at Rutgers a recipient of the Distinguished Achievements in Research Award, and she has received Best Paper Awards at SIGDIAL and ACL, as well as serving as a board member for the North American chapter of the Association for Computational Linguistics, a co-founder and co-chair of the New York Academy of Sciences Annual Symposium on NLP Dialogue Speech, and as program co-chair for SIGDIAL and ACL. And she will talk to us today about her work on human-centric natural language processing for social good and responsible computing. Smaranda.
Thank you so much, Rebecca, for the nice introduction and for having me here today. And thank everyone for being in person as well and on Zoom. And I'm excited to talk about my lab's work around work on natural language processing for social good and responsible computing, putting an accent on human-centric work. So we are in a very exciting times in the area of AI in general, and also natural language processing with the rise of large language models and generative AI. And this has a lot of impact in many domains. And if you were at the Data Science Institute yesterday at the Data Science Day, you saw the keynote speaker about the impacts they have, for example, in the financial domain. And here is a title that was in mid-April, 35 ways real people use AI right now. And I'm taking here some of the nice application or domain use of this technology. For example, copy editor for people with dyslexia, writing assistant for speaker of English as a second language. And if you're looking at images, for example, identifying disease in banana plants. And also, if you're looking and you're interacting with these models, for example, ChatGPT, sometimes you might be surprised. It's like, oh, this is doing really, they know how to reason. And this is an example I liked from Mia Jean's Choice keynote at ACL last year. If you travel west for far enough from the West Coast, you can reach the East Coast. Right, so this is the user, and then the machine responds, the world is round, so you reach the East Coast, therefore the answer is true, right? So it looks like, oh, it's impressive, it reason knows how to go, the world is round, and so on. However, is it really true that the language model can reason? Well, not really. And many, many times we see really examples of common sense reasoning that is very simple. However, these language models cannot do. And if you really are interested in all the fail aspects, Ernest David, who is a professor at NYU in common sense reasoning, he compiled a very nice list of all these failure models. So here's the user give an example. The trophy didn't fit the suitcase because it was too small. What was too small? And the model says the trophy was too small. So this is actually, they cannot reason about size, for example, and fitting. Another bad aspects of the language models right now, so is also this language model provide hallucination and wrong answers. So this is an example, like you have a prompt, which is a question, what do people, where do people smoke more on average than in Russia? And then here you see a whole paragraph, but all the numbers in red are made up, right? So these are not correct numbers if you're looking at reliable sources for that information. So we saw the good, we see the bad, and there is the ugly. And we know, for example, and you saw a lot in kind of when you develop this technology, there is a lot of issues around bias and stereotypes. Also, there is a lot of problem with exclusatory norms. So these language models, for example, they are trained on large data sets where are probably around one culture or few cultures, but they are not in the data. You don't have any information about specific culture or languages. So this will lead to exclusatory norms. We have also problems with toxicity. Sometimes the output can be toxic, data leakage, which is related with the privacy issue, and also this potential of disinformation, this wrong answer or false information can be used as disinformation devices and other potential dual uses for the technologies. So the question here is that we want to work, there is a lot of very good potential for these NLP technologies, but we want to be careful when we're designing them and how to think about that. And this is work that we as a technologists and the scientists should do, but this involves a lot of community participation, policymaker, and so that's a very big. So I want to emphasize here a research map for my lab and around the area of NLP and social good and responsible computing. And these are some of the area we've been looking at: misinformation detection, NLP for education. So how can we use technologies in the educational setting for public health, and NLP and diversity? And I'm briefly going to mention just some applications. So in the misinformation detection space, we have been looking to help journalists fact check the news or social media posts, like with these end-to-end pipelines, decided basically what to fact check, why to fact check, and how to do it, right? So you identify, you have an article, you figure out what are the statements or claims that are check-worthy, then you have a reliable source, and then you provide the system with the answer true or false. However, we need to move beyond just true or false, because a lot of the fact check news are not true or false, but they are misleading content. And we have been looking at kind of categorizing them as well as mostly true, mostly false, and looking at fallacies. And here we're doing collaboration with researchers in communication and media. If you're looking in the domain of public health, again, misinformation was very important, especially around COVID-19. So we've been looking at that. But we also collaborating with researchers in the School of Social Work and Public Health of understanding from social media how people move from use to misuse to addiction. So here the task, if you look in the example at the top, you have, let's say, a social media post, you have a user with a user history, and you want to understand all the stages of addiction, for example, addiction to recovery, to relapse, and so on. And you want to predict this, including and explaining to the user why the model makes these predictions. And then one of the very exciting new work we are looking at is predicting opioid overdose deaths from investigation reports. And here is at the bottom, it's very, very small. But you might want to ask why you want to do this task, why you are looking at investigation reports and not at the death certificates. And it was actually an article just yesterday mentioning that these death certificates are very delayed in New York, so they took up to 6 months. So having this technology and looking at the investigation report and trying to predict if it was an overdose or not, I think this would be very helpful, and basically using technology to identify reasons why, for example, it's likelihood to be an overdose, and providing explanation. It's another interesting application. We have been looking as well as educational application, and here specifically we focused a lot in the past several years at improving students' writing skills. And there is a big crisis in education in the writing instructions, and we have been looking at various aspects of writing. One is argumentative writing related with critical thinking, trying to understand students when they write an essay, are they identifying the main claims of the, for example, when they read something, they define the main claims, the claim and the premises, and we provide this argumentative structure for that. And also we've been looking at a creative writing assistance. For example, you can have helping students to provide more creative aspects, like the sky was beautiful, we generate like a blue canvas, so generating metaphors, idioms, simile, and you can see that as an instruction, for example, for students that are not fluent in English, for example. Here we have been collaborating with educators as well as experts in social and psychology for diversity and inclusion. We look at reducing racial and gender gap in STEM. And we also have been organizing series of workshops in the community about argumentation, figurative language, as well as NSF workshop on reading and writing for science. And last but not least, working on NLP and diversity, I think in a very broad concept. So we know, for example, one of the big issues in this language, like language models, If you look at Ethnologue, we have 7,000 languages. And when you train these language models, mostly they are trained, even if you're doing it in multilingual settings, in around 100 or 200 languages, right? So how can we provide and build technologies for a variety of languages? And we've been focusing on very complex type of languages, polysynthetic, for several reasons. Many of them are endangered, so they want to build documentation technologies for preserving these languages, and they are very complex. So if you look at the example here at the top, I segmented it, but this is one word. And this is an inuktitut. So this is actually the full sentence. I can't hear you very well. So try to use MT, machine translation or anything, trying to translate this, they can't. They don't even recognize it's an inuktitut. They say it's West Greenlandic language. So it's a very, very hard problem. So how you build technologies to deal with the language diversity. And I want to highlight here, besides collaboration with linguists, I've been collaborating with researchers in the Institute of Comparative Literature and Society to teach a course on multilingual language technologies and language diversity. And this was a Columbia Collaborative Award, which was at undergraduate level to teach both computer science students about the technology and how should we build technology with the language diversity in mind, and also what are the ethical implication and the policy implication for these technologies. So this was very successful. We have students that were getting the awards, kind of the best project awards in the data science across Columbia. So I think it was a very nice experience. And the other I want to emphasize is when I was the program chair last year, we introduced linguistic diversity as a special team track. And I'm very happy that this was actually picked up by conferences this year, ACL 2023 and EMNLP, to basically use this as a permanent track, which I think is very, very important for our field. Also been looking at other things like cultural diversity, for example, discovering norms, not only mostly like you have this in the American culture, but how to discover norms across various languages. So let me now emphasize key challenges and technical innovation that span across all of these aspects of the research. So one of the main challenge is the lack of training data, right? And we don't have training data which is specific for a particular task that we want to solve across all of these problems. And the need to model common sense knowledge or domain knowledge, again, it's very important. So the technical innovation here, and I'm going to highlight some pieces of work that will kind of push and to emphasize what I mean by that. We want to have these models, language models, also collaborating or, and being enhanced by knowledge-aware models, right? So we need to make this model no common sense, no domain knowledge, and ultimately no knowledge of sociocultural norms. Also, I emphasize a lot of building this model to pay attention to the theory behind the problem you are trying to solve. So, for example, looking at linguistic theories, argumentation theories, or other theories to be able to help you to even design the solution for the problem. Explainability is very important. And then last but not least, the human-AI collaboration. And here is some research recently we do a lot in building high-quality data sets. Helps humans solve tasks, and ultimately, I think as a long-term goal is aligning better with the human values, our technology. So let me zoom in some simple research nuggets that I want to emphasize across these aspects of the innovation. One is the theory-guided knowledge-aware models, and I'm emphasizing a simple problem, like a focus problem on a very important thing in argument mining and understanding argumentation, which is anti-meme reconstruction. I'm going to define next what it is. Then I'm going to focus on the human-AI collaboration. So how can we collaborate humans with AI models to build high-quality data sets and solve tasks? And I'm focusing on a specific case that it's kind of easier to show on looking at generating visual metaphors. And then the use of textual explanation with some quick insights about various projects. So let me introduce the problem of anti-meme reconstruction. And this has been used in educational. It's very important for a lot of work if you really try to understand arguments. So an anti-meme is an incomplete argument that we found in discourse where some components are explicit, but other propositions are left implicit and need to be filled in order to fully understand what the argument is. And this was actually one of the main issues also in the students' writing, that they are making linking premises to conclusion without this implicit reasoning. So if you look here at the Sherlock Holmes Silver Blaze case, a dog was kept in the stable, and yet someone had been in and fetched out the horse. He had not barked enough to rouse the two lads in the loft. Obviously, the midnight visitor was someone whom the dog knew well. Right, so the missing premise here is that the dogs generally bark when a person enters an area unless the dog knows the person well. So what we want to do is actually, can we retrieve these missing premises to make sure that the argument that is presenting makes sense? And I want to highlight this work, both from the theory and the knowledge-aware models, but also this was done with my PhD student Tuhin and the high school student who was very excited to be involved in research. And he said, yeah, sure, and then he was contributing, and he has an EMNLP paper, which is one of our top conferences. And I don't know what I was doing at high school, but I was not writing research papers. So here is the task definition. So basically what we did, we really formulate a new task for this problem and provide a solution, an initial solution for it. So given an anti-meme consisting of a stated conclusion and premise, we want to generate this implicit premise. So we form it as a text-to-text generation problem. What were the challenges? Well, the lack of training data. So we don't have data about these incomplete arguments with implicit meaning. And we also, of course, need to model common sense. So this is, it really set up the problems in general in this space. So theoretical insight, right? So when we work on the argumentation, we've been looking a lot in this space. And from the theory, it says that incomplete arguments in naturally occurring discourse more often than not require abductive reasoning, which plausible explanation rather than deductive reasoning, which is more strict. And the Silver Blaze case is such an example. So I'm going to show you how we use this insight to solve the problem of lack of training data. But before I talk about this, just for people who are not familiar with language model, I want to introduce very briefly two key concepts that I'm going to talk, which is called unsupervised pre-training and fine-tuning, because you're going to hear these concepts and I want people to understand what I mean by that. So when we build this large language model, one of the power that they have is this idea of what is called self-supervision, self-learning, unsupervised learning, or pre-training, where you basically give the model very large amount of raw data from the internet. So basically what the optimization task in pre-training is that you mask some of the words and make the model predict the word, either from the context of the next word prediction. So in this way, you might also have other things like predicting the next sentence, but this way you build this large language model that have some knowledge of representation of language. And then you take these models that you can think of them as general, task models, and then you fine tune them, which is a supervised process where you have a task, for example, given a movie review, you want to say positive or negative, you use this model, then giving this, let's say, review, you want to predict that's negative. So that's the idea of the unsupervision, pre-training phase, and the fine-tuning on the task. So here the approach for solving our problem is a text-to-text generation problem. And we use a model that's BART, at that point was in 2020. And this is a pre-training coder-decoder model. And you use here as input, you can see, right? So it's our implicit, it's an incomplete argument. Vaccination save life. Vaccination should be mandatory for children. You give them as an input and you want to recover what is the implicit meaning, right? So that will be the output. If you take this pre-trained model, you're going to get vaccination save lives, they save money, which is nonsense. It just repeats the premise, it doesn't give you anything, right? So it's really just applying blind in this model is not going to work. So we need to address the two challenges I mentioned. One, lack of training data. So what we can do is we leverage the abductive reasoning step to do that. And then we need to model common sense. And here is the idea of combining language model and large language models to be aware to include a common sense knowledge relevant to the discourse. So I'm going to show you how we do this, both of these cases. So For leverage abductive reasoning, we took advantage of the work done at University of Washington of building this abductive reasoning in narrative dataset. And the idea what they did was a crowdsourced experiment. So they took a large collection of stories, which is called rock stories, which is usually using generation and story understanding. And they took the first and the last sentence in the story, and they asked human to write a plausible hypothesis that will link the first sentence to the last, right? So if you think here, Amy was looking through her mother's old scrapbooks. Amy realized her mother had dated her history professor. And then the hypothesis which explained this connection of events is that Amy found picture of her history professor and her mother together, right? So that's kind of the implicit premise. So they build these data sets, which is the adaptive reasoning, giving these two sentences, generates that hypothesis. So you can see this is very similar to the way we are looking at this problem. So this way we have 50,000 training instances for this. So what we do, right? So we take exactly this input, the two sentences with a separator here as input to the model, and to the output, we basically put them together and we include the hypothesis. So we added this and since just to make the discourse coherent, right? So Amy was looking through her mother's old scrapbook, and since Amy found pictures of her history professor and mother together, Amy realized. So this is the hypothesis here that we introduced. So then we fine-tune this BART model on this task, and we assume that's a very similar task with what we want to do. So let's look at what happens at inference. So now we're giving this example of vaccination save life. Vaccination should be mandatory for children. And now you can see that actually the model generates something much more plausible. Vaccination save lives. And since vaccination are the best way to protect children, vaccination should be mandatory. So now we actually have these things in blue here. That's our implicit premise, right? So we are doing better by leveraging this auxiliary data set for training. Can we do better? Of course, we can add common sense knowledge to this. And this is a model of discourse-aware knowledge models that we can incorporate common sense information. So just for people that don't know the idea of the knowledge model, so here the thing is that the large language model implicitly represents some reasoning abilities, right? And I give you an example at the beginning of the talk. So they have some information because they might have some information in the, when you really train on a large amount of text, you might have represent some knowledge. However, we can do better, right? We can do better by retraining these models that already have some knowledge from the language by retraining them on knowledge graphs, right? And these knowledge graphs can be any type of knowledge bases that we have. It can be common sense, concept net, making sure, like, for example, mango is used for salsa, or person sails across ocean requiring buying a boat, and so on. So you have both event-centric knowledge bases, and then basically what you do, you take this pre-trained model and you continue training them on these knowledge structures. It learns the structure of knowledge, and then it can generalize beyond this. So this is the model called COMET, coming from Common Sense Transformer, developed at Washington. So now we can think about, can you use this? And ParaComet was a variation of this exact way, but taking into account not only the common sense, general knowledge, but also discourse. So let me give you an example here, right? So if you look at this sentence in the discourse in isolation, Ella walked around the property, and then you want to identify, which is one of the relation in the knowledge base, what was the intention of Ella, right? So if you're looking completely independently on discourse, you can say, well, maybe she wanted to get exercise. Right? So that's a plausible thing that can come up as an event. However, if we look at this dialogue before and the discourse, the first sentence was the water bill at Ella's house has been high. So basically here, what Ella wanted to figure out, if you take this into account, the intention is to find the leak, fix the pipe, and so on, right? So you have some context of the discourse, you want to improve your common sense knowledge. So you get information from the discourse and from the knowledge bases. So we use this for our task. We consider the discourse, the mini discourse, these two sentences from the data set, and then we generate these relations for both of these data sets. And for our experiments, we use some only cause type relations with respect to the first one. So here what we do, right? So we take now, very similar like before, but we augment the input with the common sense derived from this knowledge model. So Amy was looking through her mother's old scrapbook. Her intention was to find something. So we use this common sense to separate us here. Amy realized her mother was a history professor, and then the output is the same. And then we fine tune now on this enhanced input to the model. So if you look here at the inference, is that now vaccination saved life. We add this common sense that is derived from the model to stop diseases. Vaccination shouldn't be mandatory. And then what is generated is vaccination are the best way to prevent childhood disease, right? So this becomes a more plausible inference between the premise and the conclusion. So that's kind of the idea behind the model. And we tested the 3 different data sets. These were done by humans. So we have human generated premises, and we tested all the models. And what we want to do the zero shot. It means just you don't train on anything, take the model. Then we do on when we apply on this abductive reasoning task, and then when you add the knowledge, this is with the K at the end. Yes.
So, could you go back?
Sure.
So to find something, I thought that was generated, that was found in.
Yeah, so this was, so this is generated automatically. So basically what you do, you take the input, just the 2 sentences. Amy was looking through the mother old scrapbook. Amy was realized her mother dated her history professor, and you look at all the common sense knowledge with respect to the 2, and you generate. So we pick here, for example, to find something. So this is added automatically, and then you continue training the model. So this will give you an extra information that will help the model then provide better.
Well, you said something was generated by human, but on the next slide.
Oh, yes. So here it's the test set.
Oh.
Yeah, so this is the test set where we have the gold data, where we want to evaluate the model performance against. So in this case, the human generated the implicit premise. So now we're going to want to compare if the model generate versus the human and try to see if they are good enough. Yeah. Yeah, so for the automatic evaluation, we can use automatic evaluation scores. So, right, so we compare what was generated by the model with the one that was generated by the humans. And we did the BERT score, and this is an automatic metric for similarity between that. And so you can see here the models, the one that uses the knowledge has a higher score comparing both with the one that uses just the abductive reasoning. And then if you use zero shot, it's really not that great. And then we did a human evaluation, which I think it's important here because we really want to understand the logic and the plausibility. So we took example from each of the data sets and we asked human, is this plausible? Is the generated implicit premise plausible or not? And we can see that adding knowledge gives us better plausibility score comparing with when just use the abductive reasoning. So this was encouraging, and we have still a lot of work to do. The results are still not great, but this is a first step towards doing this problem. So the conclusion here is that we can use theoretical insights about the phenomena, and we used here the idea of from argumentation theory to be able to even how to think about using some useful training set to fine-tune our models. I argue for combining language model with the knowledge model to plan content and control generation system. And I think this is going to come across a different type of problems we use. I mean, I show here in this case, but it can be applied for many other instances. Evaluation metrics and methods are important, and specifically for generation tasks, human evaluation is important. And as the next steps, we are looking now and working to explore other type of common sense around these knowledge models, and also informed by what it's called the argument scheme in the input argument, right? So you might have an argument that uses a causal reasoning or an analogy or something else, right? So maybe the kind of guiding the model, thinking about what type of premise to generate more appropriately, that will be an interesting thing to look at. All right, so let me, so this is one nugget of how to use knowledge to improve and actually solve tasks in this space. And I want to emphasize the human AI collaboration. And I think this is a really important kind of next step on how we think about developing the technology and having a human in the loop to do that. And I'm going to emphasize on one case of building data sets of high quality and even for a task. And I'm going to emphasize visual metaphors. And I can motivate why I choose this, right? So again, this is a work that I've been doing with my students. These are PhD students. Arkady was actually an undergrad at Columbia. He was engaged with us in some of the research on figurative language, and he got very excited and he applied for the PhD program. So he's now first year, he's now contributing to this line of work. And they had a demo at the Data Science Day yesterday. So visual metaphors are powerful rhetorical devices used to persuade or communicate creative ideas through images. And similarly to linguistic metaphors, they convey meaning implicit through symbolism, juxtaposition of the symbol. So it's not an easy task. So if you look at this image, can you say what the metaphor is? Or guess? This is the first one. This one I'm going to explain in a second.
Yeah, like we're tracked by the microphone by our words.
That can be right. That can be
Freedom of speech.
freedom of speech, right? You might actually have that freedom of speech, the microphone and all that. It's hard, right? It's like, you have to be creative. And the reason I choose this part of the talk, I was brainstorming, what example of human AI collaboration research I've done, I choose. And I'll motivate with another, but here is the New Yorker next edition coming up on the 24th, the 1st May. And you see here this metaphor, which is really interesting. So you see the hand, and you can see them. Okay, I look at these two hands, robotic hand and the human hand is maybe human AI collaboration. You look a bit carefully, and then there's the question, who is drawing whom? The real hand drawing the machine, or the machine is drawing the human, right? So it's kind of this interesting, and it was a whole article. It's very interesting about how how we use technology and how we collaborate with technology, and what's the role of technologies in creative process. So yeah, that was like exciting too.
It's also a subversion of famous.
Yes, exactly. Yeah, exactly. So they took this up exactly. Yeah. Right, so the task definition here, so a lot of work in NLP, if you think about just language, people have focused on metaphor, and we have been doing also a lot of work on understanding metaphor from language, generation of metaphors for improving students' creative writing and so on. But we didn't really, there is not a lot of work on looking at kind of visual and looking at the visual metaphors. There have been some work at Columbia, at Lydia Chilton's group on looking at some visual metaphor through human-computer interactions, but not really looking at generating visual metaphors. And the task is to generate these visual metaphors from linguistic metaphors, right? So it has like here, he was a lion in the battlefield, and you want to generate this image. But the question is, can these new models in text to image already do this, right? So you can see DALL-E 2 or diffusion models or anything else, Stable Diffusion. They can generate very compelling images right now. And is the problem solved, right? Can we just generate directly? So here is this nice thing, a small cactus wearing a straw hat and neon sunglasses and so on and so forth, right? And generates very compelling images. Well, not really. So my whole mind is a leaking black hole. No, well, nothing. My bedroom is a pigsty. Well, it kind of it's pink. There is a pig there, very small, but no, not really, right? It doesn't really capture the linguistic metaphor. So what are the problems, right? What are the challenging? So here is like, we need to model this implicit meaning of the metaphor, and as well as objects and properties and relations that are finding a way to really properly combine them. So the two common challenges in text-to-image models are this underspecification problem, where the linguistic description of the real world scene really omits a great deal of the visual information. So the model can't visualize properly, and the attribute object binding, again, this is a very, like a big issue in the vision models, fundamental problem to more compositional generalization. So this is a very kind of interesting task. So again, I use this example of visual metaphor just to emphasize again, how can we use human AI collaboration to build data sets of high quality that then we can train smaller models. So here what we do, I want to emphasize there is a collaboration. We're going to do collaboration between language models, collaboration between these text-to-image diffusion models and the humans. So I'll give you this example, and I'm going to go through exactly how we did it, right? So you take the linguistic metaphor, my bedroom is a pigsty. If you use directly, I showed, nothing, like it's not great. However, we can use the language models, the large language models, to create a visual elaboration of these metaphors that includes implicit meaning, objects, and so on. So if you use that, we have a bedroom with clothes and garbage everywhere with a pig in the center rooting, right? So, I mean, this is much more closer to what you would have imagined that's being a visual metaphor for that. We create a high quality metaphor data set through this human AI collaboration, and then we did an evaluation for that. I'll go through that. But let me go through this whole process and just to highlight some of the things we did, which I think is some of the property of the language models that are actually important. So the first one, we take what we called this from the linguistic metaphor, and we use this instruct GPT, which is the large language model, but we did with instruction, what is called chain of thought prompting. So the idea here is you want to instruct the model almost with a step-by-step reasoning, right? So you tell what to do. Your task will be to elaborate a metaphor with rich visual details, we provide objects and include an implicit meaning, make sure to have implicit meaning in the objects and so in the explanation. Right, so it's a kind of step-by-step reasoning, and you give examples here, right? My lawyer is a shark, the objects would be lawyer and shark, the implicit is a fierce, and the visual elaboration, you provide that. And you give few examples, and this is what is called in-context learning. So this ability of the models giving instructions, plus these few examples, then to generalize to unseen cases. So, right, so now that I give this metaphor, my bedroom is a pigsty, the model will generate messy bedroom, pig, the meaning is dirty, and then the visual elaboration would be the bedroom with clothes and garbage everywhere and so on, right? So we are using these language models ability, especially to follow instructions and with few examples to generate this elaborative scheme. However, we are not done, right? We want to do a human expert verification to see if this actually makes sense before we are sending it to the visual models of the text to image model. So here is an example where if the human decides this is a good, it's sent directly. If not, the human will do some small edits for that. Like the news of the accident was a dagger in her heart. And what was the model generated is an illustration of the heart with the dagger stuck into it, dropping blood and pain in the woman's side, right? However, what is missing here, what is missing from this? I mean, it's kind of showing the aspects of the dagger in the heart and sadness and all that, but there is no news, right? So there is no news of an accident, but we want to capture that so that the human can say an illustration of a human receiving a phone call and her heart and so on and so forth. So now you have this telephone that is actually added to that, so you can, improve and iterate. So this is the main idea. And then in the end, we also do the final validation of the images, and then we select the one that that the human consider correctly. So with this, we generate a high quality linguistic visual metaphor data set where we have 1,540 unique linguistic metaphors, the visual elaboration, as well as 6,000 unique visual metaphors. So we generate approximately 4 images per linguistic input. So we did several evaluation setups. The details are not super important. What models we tested several models on the text to image side, DALL-E and Stable Diffusion and Structured Diffusion. But what I want to, when you look at the results, to compare this group of language model collaboration with the text model and just the text to image, just the image model on its own, right? So I think that would be important, and then the Stable Diffusion. We also did a human evaluation, and I think this will be was very interesting. We use illustrative designer, people that really appreciate and know how to look at these things. So we took 100 random linguistic metaphors. So their task was not only to rank the output, but also provide instructions. So if you look at the output, like, for example, very similar with the task here, right? So if you look at this image, you might want to say, well, you need to add a telephone to show the news and so on. So the human were tasked to provide instruction needed to make the image better, unless the image was perfect, or what we call it lost cause. It was so bad that you couldn't do anything, even if you give 10,000 more instruction to fix it. Right, so here what we do, we compare this model. So again, here you should look at the first line, let's say Stable Diffusion, comparing it with the next 2 lines. So we see that adding this language model interaction, it's helping And then the better results we obtain with the DALL-E model with the human interaction, and the average number of instructions is basically here close to just the 1 instructions. And this is some qualitative examples of the data. And you can see, for example, the DALL-E here is fairly okay. It's still not quite well. Like here is an example of books are mirrored to the soul. Yeah, not really there yet. So now we evaluate, well, is the human component important, right? So we took this best language combination of large language model, the collaboration between large language model and DALL-E, with no human collaboration versus using the human in the loop in the full setup. And then you use a similar human evaluation. So we see here that having the human in the loop generates definitely much better quality, and it helps improving the data set. So if you look at the example here, books are the mirror to the soul. So in this case, we actually get a better image. And we looked at seeing where the humans basically interacting by editing the language generating visual description or selecting at the end. And we also did a human evaluation setup for an extrinsic task. And this is a very, very hard task in vision. And this is visual entailment. So let me explain briefly what the task is, right? So the task in general is that you have an image and you have their caption, and you want to see if the image entails the caption or the caption entails the image, right? So in this case, this image corresponds. So basically we use the data set. So we have the metaphor. This is not given to the input to the model, but we have this metaphor. It was obscene, but she was drawn to it like a moth to the flame. So that's the image. And then the caption is, does the image imply it was obscene, so she was disgusted by it, right? And this is a contradiction because, of course, this is drawn like a flame, moth to a flame. Well, it's not really disgusted. So we built this data set from our previous work where we created parallel textual entailment models between metaphors and both the implicit, the literal meaning, as well as the contradictory. So we use that to build this data set. And this is an example where you have this image, and does the image imply her bones are chilled by the cold? And this is an entailment because the cold hollows her bones, right? But the input to the models is just the image and this instruction caption here. So we split the data into train, test, and validation with this, around 700 in training in terms of the linguistic metaphor, and up to 3,500 images. So we use that for our data set. And we tested a state-of-the-art model on visual entailment. And this is called OFA, and I think it stands for one for all or something. They want to build a very general model, right? It solves any task in vision, visual entailment, question answering, anything. So what we did, we take this model, we fine-tune it on a very, very large data set, which is particular for visual entailment, but not on this setup of with the metaphoric expression. And then we do, again, fine-tune on that data plus augment it with our data. So if you see in the original, the performance is really low. It's like 25. So, and then basically because we have a balanced data set, you imagine that just, a baseline would be 30, but it's like really, really not doing well because the task is really hard. And then if you use our data, we can, of course, obtain better improvements. So we are contributing data set that kind of hopefully will push the vision models also to do more on the understanding side of the images. So here we have we try to look at how compositional are the visual metaphors in our data set. And this was an example, he froze with fear when he saw it, right? So it's a nice, you can see, and then it's almost like freezing, and the expression of fear. Love is a crocodile in the river of desire, and so on. You have, others. So we do have these interesting aspects of compositionality in the data. So what is the conclusion, kind of the next step? This is again, as I mentioned, this is some very recent work we're doing. Is under review right now at one of the top conferences in our field. And so we have this collaboration between large language model and diffusion, these text to image models, and human, which seems a promising avenue for generating visual metaphors. The data set introducing a very hard task for the image language image models on visual entailment. But what is very interesting, I think, as a next step, what we are looking right now is that we have these user-provided instructions of how to fix the image and take those and then use them as input to fix the models, right? So you're kind of having this continuum human AI collaboration to solve the task. And then we use this also, like some of my students are interested in having also like some undergraduates working on using this for illustration in stories. And so on. And please interrupt if you have any questions. If not, I'll go to the last piece and then I'll come back to kind of the big picture at the end. So I show this how we can do human AI collaboration to solve tasks. And then I want to also focus a bit on textual explanation, because I think that will be an important features as we move towards more kind of explainable AI for end users. And I want to give you 2 quick insights. I call them, this again, it's a full research direction. So I'm presenting it in 1 or 2 slides just to give you an intuition. So one is we are looking at discovering these cross-cultural norms. And a lot of work that has been done in our field is focused on one culture, right? So I think the question is like, can we use some of the technology or build data sets that will allow us to study these cross-cultural differences? So what we did, again, here is another example of using a human AI collaboration framework to build a novel data set of situational line pairs between Chinese and American norms, but with textual explanation. So I want to emphasize the textual explanation part here. But just to give you a brief idea, right? So we start with, there is this very large data set that was created by crowdsources, like basically by humans, looking at the US cultures where you have situations and then the norms that are relevant to the situation. So, right, so one norm can be, for example, in this case, it's okay to ask for your money back, right, when you lend someone the money, and then we want to see, can we automatically find situations that are relevant for a different culture? So what we do is actually we look at Chinese, and this is part of our cross-cultural understanding grant that we are working on. So we're looking at Chinese, and there is this question answering website and discussion forum is called Jihu, where people go and ask questions about etiquette and how to behave in different situations. How do I do? Is it appropriate to do this in this business environment? Is it okay to do that? So you have the questions, and then you have the answer that kind of tells you more or less the explicit norms in that. So what we do, we align the situation in the US, like from this social chemistry 101 with Chinese situation using cross-lingual alignment models. You do very high similarity score. And then we use this GPT-3 few-shot prompting to extract candidates' Chinese norms. And then we use a very similar idea what I presented before of chain of thought prompting to extract, not only to say which is the norm more relevant from the Chinese, but also to predict, given the English norm, the US norms and the Chinese norm, what is the relation, entailment, which means the same, contradiction, which means they are different, or there is no relation between them. And then again, here we use a human expert feedback. We collaborated with someone in the School of Communication, expert in cross-cultural knowledge and research. And so we build this data set now that you have this US relation. Okay, so it's okay for you to ask for the money back in the US, but it's not polite to ask for the money back directly. And then you have a contradiction here and the explanation that is generated to explain why this is a contradictory relation. So here the big part here is this explanation. So now the task becomes, well, so we build this explainable textual entailment model. So given a situation and the Chinese and American norms similar, are the norms similar, different, and why, right? So we want the model, and this is what is called self-rationalizing models, and this will be becoming more and more important, is that you give the input, but you want to make the prediction, like which will be the label in our case, entail or contradict, but also the explanation. So why is then a contradiction or an entailment relation? So we did that and we built the data. And then the other thing I want to highlight, we can also start to think about novel metrics of evaluation, not only looking at the prediction accuracy, but also looking at the explanation quality. So we can look at some, for example, prediction of accuracy at some explanation scores. Yes, sure.
I was thinking of entailment as not a symmetric relation, right?
Right.
Entails the explained.
Right,
whatever.
right.
But it seems like here you're.
Here is gonna be, yeah, so we call it general so that it fits in the framework of entailment. So usually it's the text entails the hypothesis, but in case of paraphrasing, you're gonna have that it's basically both ways. You can one or the other. In this case, we tested, I think, coming from one of the norm, the English norm to the Chinese norm, but I think it should be bidirectional relations between them. And we can do that in both ways.
And would you maybe find that in fact, since you want it to go both ways, you can use that as a, to check.
Yes, exactly. Yes, we didn't run it that way, but I think it should be. So then if one it doesn't, then it's maybe no relation or something. It's more like it's much more. And this would be interesting to see even from a social science perspective is one, and is it the model making out of tradition, or is there something where you have these asymmetric relations?
On the previous slide, how are the alignment similarities? Assuming it's the similarities of the situation.
Yes, yes. So for example, you can see the situation here is I give money, like I give my friend $5,000 or something, like a sum of money, right? And then you have, this is the situation in English. And then what we do alignment similarly with the Chinese question. So there you can have questions like, if I lend my friend money, can I ask the money back, right? So this is a question that people ask, is it polite or not? And people will say, yeah, in general, it's good or it's bad or you shouldn't do it. Yeah, so the alignment, this is actually from the discussion forum. So the question is, from the discussion forum, the norm is extracted automatically using these prompting methods from GPT from the answers. So you have answers that is given by someone and you extract what the norm is. It's almost like an explicit norm extraction. You can see the information extraction stage. You have human validation in this stage as well. And then because you have the chain of thought prompting where you try to see which is the norm that is more related to so you have the human in the loop to validate that. Yeah, and that's why we only have, like I said, right now we have 3,000 situation, but this is still a good purpose. All right, so then the other study here, I don't going to emphasize more, but I want to show you another case, another type of explanation that will be important. So this is the work that we're looking at, which is the long-term goal is to study social media to understand people's move across the opioid use disorder. So like people moving from addiction to recovery to relapse. So the first step we look at, and this is collaboration with the School of Social Work, is we look at social media platform, and Reddit is a good one because it's anonymous and people can post without fear of stigma about their personal experiences with addiction. And we look at subreddits like opioids or drugs or opiates recovery. And the task is very limited in this case, right? So we don't look across user. We are now in the next stage. We're going to look at that. But for this particular piece of work, we look at giving a user post in a community-based social media. Can we predict what they are talking about an addiction or recovery or misuse or relapse and not using? So we want to make this prediction. And then what we actually did a lot of work on annotations, both novices and experts annotations. And we looked at, so the big result is here is that using this textual explanation, or sometimes because there are fragments from the post that explains, for example, why the label is given, or it's called also rationale. But this is another type of textual explanation that helps the model predicts better. And this is across several methods of using different type of few shot learning or fully supervised, also making the prediction of the explanation as well. So coming back full circle to my first kind of line of work. So I'm starting first with the outer things, which are more on the technical side, and then I'll zoom in more also on the social good and responsible computing part. So I think going forward, I think that really, I believe that the technology and the model should combine both the language models, so they are really good, but also the idea of knowledge and knowledge models, so training and learning from data and knowledge. And we should combine common sense, domain, and also social cultural norms. I think that will be very important. And because we actually have these more powerful models that include the knowledge, we can actually aim to build smaller model rather than these, like, ones that you can run on many GPUs, or you cannot even run it at all. Theory-guided models, again, will be important. Use insights from the problem you are solving to guide how even to design the solution to the problem. Explainable models are important, evaluation and metrics. And I think the human-AI collaboration should become a very important piece in this work of building high-quality data sets, helping humans solve tasks, and ultimately align better with human values. And again, here we should think about very carefully who are we designing the system for, and how should we think about the problem. So in terms of the kind of applications and impactful on social good and responsible computing, I'm looking still to continue work on the misinformation, particularly focusing on this notion of fallacies, and maybe even going a step forward, which I think will be very important, is to think about this psychological concept of fact meet fallacy, because you want to explain why it's a fallacy. Otherwise, people will not be convinced, like, why should I don't believe this thing? In NLP for education, we're going to look more into this human-AI collaboration for helping students with different creative or argumentative writing skills. In the public health, it's this new project with the chief medical examiner in New York of looking at investigation reports to predict the likelihood of opioid overdose. And then in the NLP and diversity, continuing working on linguistic diversity, cultural diversity, and been starting actually a work to look at detection of anti-inclusive speech for that. So I think we as technologists can make advances, and we should make advances. However, to solve the problems, we should have interdisciplinary approaches to this. So we should talk with people in different domains like health, humanities, ethics, and so on. We also want community and policymakers involved in that, cross sectors, not only university, maybe industry, government, and then also primarily education. I think it's very, very important to start educating students, and both to learn the technology and how to use and how to develop responsible technology for the future. And last words. Metaphors are not to be trifled with. A single metaphor can give birth to love. This is Kundera, and this is one of my favorite quotes. Well, I regenerate this to show my vision of theoretical insights, knowledge-aware and interactive models, high-quality data sets, evaluation methods, and metrics are not to be trifled with. They can give birth to love for explainable natural language understanding, generation for social good and responsible computing. I just want to thank my PhD students, postdoc, undergraduate students I've been working on the past few years, master students, and the domain experts, and questions.
Great, thank you, Smaranda. Questions for Smaranda, and if you're on the Zoom, you can unmute or you can type in the chat and we'll ask your question for you.
I guess one natural question for computer scientists is to what extent does a training also on code allows, to what extent does that allow in getting some logic built in?
Yes, so there is a lot of progress. I think a lot right now on the models, like for example, we can say it's just language model. It's not true because they're trained a lot on code, right? And this is almost like a symbolic mapping between commands and stuff and code. So this is it kind of gets better at reasoning. And these of the large language models, the knowledge model aspects, it's one key to do that, because you can transform all the really big knowledge bases in more or less triplets, entity relation, and you generate the other entities, and then you can keep training the language model. So the idea is like exactly that, right? So how can we incorporate this knowledge in a way that it becomes, the reasoning becomes almost like a natural language reasoning process, and we can use. So yeah, I think that's it. And then also the domain knowledge, I think that would be important to model. So the idea is exactly that what I'm thinking about, data, learning from data and knowledge, ideally at the same time or combining them. And then the other thing I feel like we should is like the planning. Chain of thought kind of gets there, like reason step by step, but I don't know how to plan. And this is not yet part of this model. So yeah, that's
And we have a question from Lisa Soros in the chat. Do you have any interest in or ideas for mitigating the environmental impacts of training large models?
Yes, so this is the little thing I mentioned here, smaller model, right? So the idea that if you look at some of the models that we have been looking for actually training, they are it's a smaller size. So the Barnard model, it's let's say 1 million parameters versus this 175 billion that are really, really large language models. So the idea, if you can combine this smaller language model, but with adding the knowledge and other information, then you can actually run this smaller model. So you can use what I think here is important. We can leverage the larger language model to generate data sets in a human AI collaboration, and then use these data sets to basically build a smaller model for that. So I think this will kind of solve, and it gives also the universities a way in this space, because a lot of the large language models is done on all these companies that have large resources, right? So I think we should work smarter to build better models, but smaller, yeah.
Yeah, and actually that leads into the question I was going to ask. So, and you answered one way here. So, which is sort of what is the right way now for university research to exist and exist on its own and or collaborate with industry research. And so one is right, smaller models but do you have sort of a higher level thought of how industry and academic research can work together best in this space at this point?
Right. So I think the idea of, and you can see very similar on this, like Stanford released this smaller model of Alpaca, which is basically really using the larger model, OpenAI, generating small and then training that. So I think kind of going into that space. I think almost, I really think that the data sets, which have been it's in NLP field for like very hard problems, it took ages to build a good data set. So kind of leveraging this possibility where we can kind of get some annotations with the human in the loop and generating data sets faster to then build smaller model. I think that's another way too. And then I really think what is very important also the smaller model and everything, the alignment with the human values. I think that's also like, I think where I see the academia also putting more effort into that. Of course, the industry is paying attention to this, but I think like, academia can do more work into this space.
More questions? All right. Thank you again, Smaranda. Thanks so much for coming.